Well, this lecture talks about how to create and use dummy variables for nominal level predictors. So let's look at this R script. Right? So at the very beginning, of very generic procedures like how to, remove, active objects in the global environment and set up working directory, invoke form package and reading stated data file. Next is to select variables, and we use loop. Down below, I use the lapply function to loop through all the variables in my DTA and data frame object to produce descriptive statistics. Next step is to create a binary response variable, which is not the focus of my lecture today. So let's focus on creating dummy variables for binary covariates. In this case, is sex. We know sex is coded as 1 for male and 2 for females. So here, this line. What this line does is to create a dummy variable for sex with female used as the reference category. When we say female used reference category, that means female is going to be coded as 0 and male is going to be coded as 1. And as was done in this line, right? So as dot numeric parentheses my DTA $ sex. So for the sex variable equal to 1, and that is for male, it's going to be coded 1. Otherwise, for all other cases, it's going to be coded as 0. Similarly, we can create a dummy variable for sex with male, in this case, as the reference category. Okay? So when we say if we're going to use male as the reference category, then male is going to be coded as what? As 0. And females going to be coded as 1. That's exactly how this was done right here. So I create a new variable female in this my DTA data frame. When sex is equal to 2 in this data frame, my DTA, if sex is equal to 2, female going to be 1. And all other cases going to be coded as 0. So in this case, I created 2 dummy variables, okay, for this binary indicator covariate or variable, right? The question would be, should we use both dummy variables in our regression analysis? Well, later on, we explain that. So let's move on to a more complicated case. That is to create dummy variables for multi-category variables, okay? So in this case, we have race, right? If you look at our code book, we know that race is coded as 1 for whites. It's coded as 2 for blacks and 3 for others, okay? And the question that naturally comes out of this coding schema would be whether we can use this numerically coded race in our regression analysis directly. That is, we use race in our regression analysis. The answer is no. The answer is no, okay? Because otherwise, that would mean, well, black is twice the value of white, and other is triple the value of white, right? And there's a numerical relationship among the 3, which does not make any sense, right? So what we want to do is to numericalize or quantify this nominal level variable race. The best solution would be to create dummy variable. So in this case, we're going to create a dummy named white, okay? And when race is equal to 1, okay, that is, when the racial identity is a membership is white, then this white dummy variable gonna be coded as 1. So when For this if-else function, the first argument is condition. When this condition is satisfied, it's going to be assigned a value in the second argument. Otherwise, it's going to be assigned a value in the third argument. In this case, 0. So for this y dummy variable, okay, when the respondents are white, then it's going to be given a value of 1. Otherwise, including black and other, both going to be coded as 0. We're going to do the same thing for black. Okay, so first we specify this condition, right? If race is equal to 2. When this condition is satisfied, well, the respondent going to be assigned value of 1. Otherwise, including white and other, going to be assigned a value of 0. We're going to do the same thing for other, right? So when this condition, it is race is equal to 3, that condition is satisfied, then the respondent going to be assigned a value of 1, okay? Otherwise, including black or white, going to be assigned value of 0. Of course, after a recoding and creation of the dummy variables, we can do cross tabulation of the newly created dummy variables here, y, black, and other, was the original race variable for checking purposes, right? The question again is, how many dummy variables of race should we use in the regression? Well, the answer is, if we have k categories of a multi-category variable, we can create k dummy variables like I did in this case, right? We have 3 categories for race. I create 3 dummy variables for each category, right? Each category going to be coded as 1 respectively in their corresponding dummy variables, and otherwise going to be coded as 0. But how many I can use in a regression? Well, here is rule of thumb. In most cases, 99% cases, we're only allowed to use k minus 1 dummy variables in a regression analysis, okay? And the omitted category going to be used as the reference category. That is, the omitted category going to be the category that's going to be compared to in our interpretation of the results. You will see that pretty quickly. And next step is to have cross tabulation of newly created dummy variable and the original race variable. Okay, and in R, okay, sometimes people say, well, creating dummy variables, that can be tedious and error prone, right? I agree to a great extent. So R has this nice feature of factor variable. So if we turn a variable, in this case, race variable, into a factor variable, okay, once that's done and the data frame recognizes that race now has become a factor variable, which was not, okay, after we read in this data file. After it's turned into a factor variable, then we can directly use this factor variable, and dummy variable is going to be created automatically by the majority of our estimation functions. Okay, there are always exceptions. Okay, and I will explain later. Right. The next step is to drop missing cases. So nothing that is outside the usual scope of data management.